On the island of Madagascar, there is a farm owned by Farmer Earl. Farmer Earl has a few chickens on his farm, which lay a different number of eggs every single day. Now, Farmer Earl wants to know how many eggs are laid in total per week over 4 weeks. He creates a table that contains the amount of eggs laid per day for 4 weeks. To calculate how many eggs are laid per week in total, he needs to add the amount of eggs laid on individual days across 1 week and then do the same for the next week and the next week and the next week. Now, obviously, the amount of eggs need to be stored in a data structure. This brings us to 2D arrays. But first, let's backtrack a little to how 1D arrays work. A 1D or one-dimensional array is a data structure that can be pictured as a single row of elements. Each element, we could say, is found in a different column of the single row. Here we see an array made up of the numbers 34, 53, 23, 44, 72, and 64. 34 is located at the first position of the array. However, in programmer speak, it is located at index 0. To access the value at the first position of the array, we write the name of the array with a square bracket enclosing a number next to it, indicating the index of the element that we want. So if we wanted to print the value at index 0, we would type system.out.println array1 with an open square bracket, 0, close square brackets. This prints out 34. To get the value at index 3, we type system.out.println array1 open square brackets 3 close square brackets. This prints out the value 44. Now, if we wanted to print out every element in the array, we would use a for loop. For an explanation of how a for loop works, please watch my video on for loops found in the description below. But in a nutshell, what would happen is that we have a for loop that contains the variable column. Column starts off at 0 and increments to the value of the last index of the array. As column increments, we print out the value in the array at position column. Now, moving on to 2D arrays, what we have is a data structure that is essentially a series of 1D arrays stacked on top of each other. While a 1D array is a single row of multiple columns, a 2D array is made up of multiple rows of multiple columns. A 2D array may have a row containing the same amounts of columns or each row containing different amounts of columns. If each row contains different amounts of columns, then the 2D array is called a jagged array. Now, to access a value in a 1D array, we only need one square brackets indicating the column index, as we assume that the column is in the row with the index 0. However, since we have both rows and columns in a 2D array, we access a value by using two square brackets. The first one indicating the row index, and the second one indicating the column index. So, looking at some code, we have a 2D array called toDimArray, which has already been populated with values. Now, when creating a two-dimensional array, we can either create it as an array pre-populated with values, as we see here, in which case the computer will assign a certain amount of memory for the array, or we can create an empty 2D array, which we have to populate ourselves. Here we see an empty array created, which is assigned enough space in memory for 5 rows and 4 columns in each row. In both cases, the size of the array cannot be readjusted once it is created. Looking at the array in our code, how would we access this element right here? Well, it would simply require us to type the array name and reference the row and column. So to print this element, we would run this line of code. Now, how would you print out every single element in the 2D array? One option would be to run system.out.println while manually referencing each index in the array. That option is extremely inefficient. We could also possibly use the for loop that we used for the one-dimensional array. Now, since this array is made up of multiple rows of one-dimensional arrays, we need to run the for loop used to print the one-dimensional array many times for each row. Now, the for loop to print the element in a row will start off at column 0 and move on up till the last position in the row, or essentially the length of the row minus 1. To get the length of a particular row in a two-dimensional array, we need to type the name of the array with the index of the row in square brackets. When we run this loop, we get the output shown here. Now, there are 4 rows in this array, so we need to run the loop for each of the 4 rows, adjusting the row number for each one. Now, this approach of copying and pasting is okay for an array with 4 rows. But what if we had an array with 500 rows? Would we copy and paste the for loop 500 times? Obviously, the answer is no. What we would actually do is surround an individual for loop that prints the columns in a row of a particular index with another for loop that causes the row of focus in the original loop to increment up until the last row in the array. So this for loop runs from 0 up until the last row in the array. To get the number of rows in a 2D array, we simply write the array name with dot length next to it. No need to specify which row with square brackets, like we did in the original loop to get the number of columns in a row. By running the code at this point, this is the output that we get. Now, having gone through this, let's get back to Farmer Earl's farm. If we recall, Farmer Earl wants to find out the number of eggs that his hens lay per week. So moving to the code, we have a 2D array made up of a series of 1D arrays representing the amount of eggs laid per week. If you would like to attempt to code the solution to this problem, you can pause the video here and resume when you are done. So moving on to the solution for Farmer Earl's problem, we first start with a for loop that adds every value in a row and prints that sum. The code at this point only works to find the number of eggs laid in the first week. Thereafter, we wrap that for loop in an outer loop to traverse each row and print the sum for each row. We of course need to readjust the variables a little from what was originally found in the code applying to the first row. At this point, the loop adds the values in each row, printing the sum as per the needs of Farmer Earl. This brings us to the end of this explanation on 2D arrays. Thank you for watching.